Today I'm going to do a little overview on my leader audio generator LAG-26. I picked this up a few years ago when I got back into electronics, and I think I got it for around $50. And the reason I still have it is because my workbench is a little small and this unit is quite small. It's not even like 12 inches wide, and it's easily portable and lightweight and works good all the time. So that's basically the reason that I kept it. I think this thing came out in somewhere around 1980 or so. I don't exactly know how much it cost. I would have to go online and try to figure it out. But I'd venture to say it probably didn't cost more than $200 or so. But still, it's a good for the money. I think it's a very good unit. I haven't did anything to it. I haven't changed any capacitors. In fact, I haven't even opened it up. It's always worked just fine. It puts out a sine wave and a square wave, and both of those waves look good. So I just basically left the thing alone. As far as the output is concerned, the frequency range basically is from 20 hertz to 200 kilohertz, and you've got 4 different decade bands or ranges here, which you can go ahead and switch. And then of course you got your variable. You have a variable control here to basically dial the frequency in. Again, it puts out a sine wave and a square wave. I think the sine wave is 5 volts RMS, and the square wave is 10 volts peak, basically 10 volts peak to peak. And the distortion is supposed to be around, I think it's from 200 hertz to 20 kilohertz, it's 0.5%. And from 20 hertz to 200 kilohertz is less than 1%. Now, I've checked this before with a distortion meter with the HP334A, old school kind of very solidly built distortion meter, and this had a lot. The leader has been very conservative with their ratings because the distortion level is, I can tell you that's somewhat lower. I think it was, just off the top of my head, I think it was 0.05% at some different frequencies that I checked it at. And the output is supposed to be flat from, it's supposed to not deviate more than 1 dB over the whole frequency range. Of course, if you do audio work, you do need a low distortion audio generator because that is important. If we just take a quick look at the face here, of course it's got just your regular dial here, dial control, so you can dial in frequency. And also we have, of course, your on-off switch. You've got a neon lamp here. Here you can switch between square wave and sine wave. And this is the sync function. Now, I've never used this thing before. In fact, I've never used it at all, any kind of sync function before. But I think what you can do, you can use an external frequency reference. Say, for example, if you had a sine wave that was very stable, but it wasn't exactly clean, you could put it in here, and this basically, then you'd have a clean sine wave coming out that would be very stable. Now, I haven't tried anything like that. I think that's kind of how it's supposed to work. You'd actually have to go ahead and try it out and see what it actually does. Now, if we come over to the right here, it's got basically a step attenuator here. This is the attenuator, and the difference between the low and the high position is about 20 dB, or rather the low position is going to be about 10 times less than the high position. Let's say if the low position was 100 millivolts. The high position, of course, would be 1 volt, because 1 volt is 10 times more than the basically 100 millivolts. And here you can, this is the fine tune the attenuation. Like this isn't for frequency. This is for the basically the amplitude. And here you've got, it doesn't have a BNC. It doesn't use BNC connectors and doesn't use a shielded cable. So if that's important to you, then you might have to, you could probably maybe add different ones here, or just buy a different audio generator altogether if that bothers you. And what else did I want to say here? Here's your output. The output impedance is 600 ohms. So now if I attached a 600 ohm resistor across the output, the voltage should be half of the, basically the unloaded voltage or the open circuit voltage. I don't know if I just mentioned it here. I'm getting ready to attach the voltmeter probes here. These things are called binding posts. You can use a banana type plug, or you can basically put a wire down in here, put something down there, and just basically tighten this back up. Now here's the unloaded voltage. You can see it's putting out basically around 5 volts RMS in the highest setting. The only thing I did notice, which was weird, is in the manual I have, it says if you hit this switch here, this attenuator, it's supposed to drop by the voltage is supposed to drop by 20 dB, which I think is 10 times less. But now if I do it on mine, it's actually 50 millivolts, which would be 100 times less for some reason. Now I don't know if they did a design change and it's not reflected in the manual. That could be also, because I don't think there's anything wrong with the circuitry, because this is exactly this 5, basically it's very close, 5 volts, and 100 times less is about 50 millivolts right there. Well, it's 49.7, but it's really, really close. So that's basically the only way I can explain that. And also, here the maximum here in the low position is 50 millivolts, and of course I can take this all the way down to 20 or whatever, even less. Now if I go to the high here, the 5 volts, which is 100 times as much as the other setting. Now I can get this all the way down to, I think, almost about, yeah, I can get it down to 50 millivolts or so. So there's, and I can get a little bit lower than that. So this actually makes sense. There's no gaps or anything. So it is a little bit odd, but there's nothing wrong with the audio generator. I'm now taking a look at the square wave output, and this is 20 hertz, and you're probably thinking, well, this is like, that square wave looks terrible. It's not square at all. That's correct, but that's of course because I have the oscilloscope in the AC position for such really low frequencies. I go ahead and use the DC position here, and you can see now the square wave is looking exactly like a square wave. Next I'm going to go ahead and run it up to the other extreme. I have to go ahead and shut the camera off now, since I'm holding the camera in one hand. Here's the other extreme now, 200,000 hertz or 200 kilohertz, and you can see that the edge here is a little bit rounded, which means it's a loss of high frequencies. But then again, this is not rated out to 200,000 hertz. This is rated from 20 to 20,000 hertz, and within that range, I'll guarantee you it's going to put out an exact good-looking square wave. So this is well within specs. Now this is the actual extreme that it's rated for, 20,000 hertz. Man, you can see there's no problem whatsoever with the square wave. And now just to bring this all to a conclusion, you can see this is a 200,000 hertz sine wave, and it's got no problems with that either. Now here's a 20 hertz sine wave, which, well, looks like a 20 hertz sine wave. So to conclude, if you're looking for an easy to use audio generator and it doesn't bother you that it's an older unit but the unit still works fine, I would recommend getting this thing. Again, it's easy to use, it's lightweight, doesn't take up much space, it works good, it's unproblematic, and you don't have to spend very much money to get one nowadays. And if you don't like it, you can always resell it, because if you buy one of those new Chinese ones nowadays that cost just as much or more, you can try to resell those, but they probably don't have really any resale value. So again, I would recommend getting this if you're into the retro stuff or the old school kind of stuff, especially if you're doing basic audio work on stereo equipment back from that day. I mean, that's when this came out. This came out during the golden era of hi-fi. Now anyways, thanks for watching.